You guys already know about regular right angle trigonometry, SOHCAHTOA, sine, cosine, tangent, how to find a side length, how to find the measure of an angle. The problem with just knowing that is that it only works if a triangle is a right triangle, so it has a right angle in it. So if you come across a triangle like this doesn't have a right angle. And so you can't use sine, cosine, or tangent on it. And so we have this thing called the Sine Law, which is going to work on some of these what are called oblique triangles. It's called an oblique triangle if it doesn't have a right angle in it. So triangles are either right triangles or oblique triangles. The Sine Law, actually it does work for right angle triangles as well, but we're going to use it mainly for oblique triangles. So one important thing before we get into what the law is and how to use it is the labeling of a triangle. And we did this before, I think, but this is important. We use capital letters to label angles. So this is triangle ABC. Those are the angles, capital A, capital B, capital C, but we use the lowercase letters for the side lengths. And the way that it works, uppercase angle A is opposite lowercase side A. And it has to be that way. So you see this angle C is opposite side C, angle B is opposite side B. So no matter what they're called, it works that way. So let's look at another triangle here. And if I label this one P, Q, and R, then what would I call this side down here? Right, lowercase q. And this one? Lowercase p, right. It could also be called uppercase q, uppercase r. Sometimes you see them labeled that way. But for the purposes of this, we're going to call it lowercase p. And this one over here, the last one, is lowercase r. That labeling is important. So this is the sine law. And the sine law says that the ratio of a side length to the sine of the opposite angle is a constant for any given triangle. And what that means is this. A divided by sine A is the same as B divided by sine B, and is the same as C divided by sine C. This is the sine law. We only ever use two parts of it at once, so I'm going to show you on the next slide how you use it. But this part here is the actual sine law. So here's a question. It asks to find the length of side C in this triangle ABC. If we're trying to find side C, then I'm going to write the sine law like this. C over sine C equals, I don't know yet what I'm going to put, but we start with what we're trying to find. We're trying to find side C, I put that on the top. And then underneath that has to go sine C. These have to match up, C and C. And then I'm going to decide, do I want to say it's equal to A over sine A or B over sine B? And the way that I decide is based on which information I have, which side length I have. Which side do we know the length of? B, so I'm going to say it's equal to B over sine B. I don't want to use A because I don't know the length of side A, so I'm not using the A part of it. I have to look at what side length am I trying to find, and what side length do I already know. And those are the letters that I'm going to use. And then just fill in the information. C is what we're trying to find, but I'll put that over the sine of, what is the measure of angle C? 105. And then B is 7 over the sine of B, which is 35 degrees. And all I have to do now is isolate the C in this equation. I do that by multiplying by sine 105 to cancel it there. and I get C is equal to 7 over sine 35 multiplied by sine 105. And that I can put in my calculator. Here's another question for you to try. Find the length of side x. Here you can see the answer worked out, how you get to 8.5 for side x. The second one is like slightly more difficult, but really not that much more difficult. Start out with, we're trying to find q, so we're going to go q over sine q. And then we need to decide what we're going to put in the other ratio. It has to be the side length that you know. So it has to go p over sine p. So we'll put sine angle Q is 87. P is 21. But here's the problem, right? What's the measure of angle P? 18. And it's 18 because of the triangle angle sum theorem, which says that all of the angles in a triangle have to add up to 180. So if you do 180 and subtract 75 and 87, means that one is 18. And when you put all of that into your calculator, you find out that Q equals 67.9 centimeters. It doesn't really look like, when I saw that number, it didn't seem right, but these angles aren't measured accurately, so you really can't tell by looking at it. But there you go. This is the last thing that we're going to do. Find the measure of the indicated angle. So see the one at the top that has just a theta in it? That's what we're going to try to find. So let's call that A. We'll call this B and C. The difference when you're trying to find an angle is you flip the whole sine law over. So instead of going A over sine A, we're going to say sine A over lowercase a equals, because A is the angle we're trying to find, I'll start with sine A. The angle that I know is angle B, so I'll do sine B over B. So we literally just take the reciprocal of the entire sine law, and because they're ratios, this will work. So we'll go sine A over 7.5 equals sine 45 over 8. And so we need to isolate the sine A. So we do that by multiplying by 7.5. So we have sine 45 over 8 multiplied by 7.5. So when I do that on my calculator, I get 0.66291267. So, yeah, I could round that to 0.66. Do you think the measure of that angle is 0.66? No, what do I have to do? Think back to when you were finding angles with regular right angle trig. What do you have to do on your calculator?
Oh, the negative?
Right, you have to do second sine, right? Because we're not, if I just put all this in, the sine 45 over 8 times 7.5, that tells me what sine A is equal to. I want to know what A is equal to, so do the inverse sine of all of that stuff. So now that I have this 0.66 whatever in my calculator, I'm going to go second sine and then second negative, which takes that answer and puts it back in. Hit enter, and then I get A is equal to 42 degrees approximately. Usually we're going to round an angle to the nearest degree. which would make it 42.